All right, so our agenda for today, we'll start by taking notes in our notebooks. Once you are done with that, you will go up, show the substitute your notes, and they will give you the in-class worksheet, which is the unit circle. So you will then keep watching the video, fill in your unit circle with me, and then once you're done with that, you will show the substitute that you filled in your unit circle, and then you will then grab tonight's homework. And you have the rest of the period to work on your homework. So by the end of class today, you should be able to use 30, 60, 90, and 45, 45, 90 triangles to find our different trig ratios, and then find reference angles all along the unit circle. So let's do a little bit of background information. So the unit circle is a circle whose center is at the origin and has a radius of length 1. That's why it's called the unit circle. Whoopsies. Whoa, I have no idea what just happened. Hang on. That's better. So, radius of length 1, which is why it's called the unit circle. So, if we have a coordinate plane, we have our origin. If I go 1 unit to the right, 1 unit up, 1 unit to the left, 1 unit down, that is my unit circle. So how do I find coordinates along my unit circle? Well, right off the bat, there are 4 easy points. Right, the 4 points that I plotted. Let me make this bigger. So right off the bat, there are 4 easy points, the 4 points that I plotted. We have that point, which has the coordinates 1, 0, that point, which has the coordinates 0, 1, that point, which has the coordinates negative 1, 0, and this point, which has the coordinates 0, negative 1. So we have 4 easy points, the 2 vertical and the 2 horizontal. All the other points you can get by creating a triangle, a right triangle to be exact. And using trig. So, what do I mean by that? Well, let's make this a little bit bigger again. There we go. And let's see, let's pick another color I haven't used yet. I'm going to go pink. Okay, so let's say I want to find a point, this point here, which has the coordinates x, y. So I can create a right triangle which has a leg measuring x and a height measuring y, because in order to create that triangle, I went right x units and up y units, and has a hypotenuse of length 1. Theta is theta. It is the angle that's made with the terminal side and the initial side. So if I want to find x and y, I can do some trig. So let's do sine cosine. So if I do sine of theta, I know that's opposite over adjacent, so in this case, that's y over, I'm sorry, opposite over hypotenuse, which in this case is y over 1, meaning sine of theta is just equal to y. And if I want to do cosine of theta, I have cosine of theta is equal to adjacent over hypotenuse, so x over 1. So cosine of theta is really just equal to x. So all along my unit circle, all of my x coordinates are just cosine of theta. All of my y coordinates are just sine of theta. So we can get all of our coordinates in the form cosine of theta, comma, sine of theta, right? X, comma, y. Tangent, on the other hand, as we talked about yesterday, is just sine over cosine. So in this case, it is y over x. So if I ever want to find tangent of theta, I know it's going to be my y coordinate divided by my x coordinate. So most cases when you find cosine of theta, sine of theta, it's a decimal, an irrational number, or possibly a number that we can't contain even as a radical. But yesterday we learned about two very special triangles, our 30, 60, 90 and our 45, 45, 90. So it turns out that if you want to get exact values around the unit circle, we will need to use our special right triangles. So the 30, 60, 90 or the 45, 45, 90. Right triangle. So we'll want theta to be 30, 60 or 45 because we know that we can get exact units. So in the case of our unit circle, well, actually, let's write those first. So I'll have my 30, 60, 90. Which opposite the 30 is x, opposite the 60 is x root 3, opposite the 90 is 2x, and my 45, 45, 90, right triangle, which has opposite the 90x, or sorry, opposite the 45x, opposite the 45x, opposite the 90 is x square root 2. But if it's the unit circle, we know that our radius is equal to 1. It means that our hypotenuses are equal to 1. So in the case of our 30, 60, 90 right triangle, if my hypotenuse is 1, it means the opposite my 30 is 1/2, and opposite my 60 is 1/2 times the square root of 3, which is square root of 3 over 2. And my 45, 45, 90 right triangle, if my hypotenuse is 1, I know that that's equal to x square root 2. So I know that 1 over square root of 2 is equal to x, or x is equal to square root of 2 over 2. So my two sides are square root of 2 over 2. So we're going to use those two triangles to fill in our entire unit circle. So at this point, go ahead and I'll pause this video and go up and grab the in-class notes. It will be 2 unit circles. All right, so now let's go ahead and let's fill in our angles first. So the first reference triangle that we're going to use is our 45, 45, 90 right triangle. So 45 degrees is pi over 4. So first I want us to fill in all of our angles in terms of degrees. So we have 0 degrees. This is 45 degrees. 45 plus 45 is 90 degrees. 90 plus 45 is 135 degrees. 135 plus 45 is 180 degrees. And, oh, I can't even see my whole circle. 180 plus 45 is 215 degrees. 215 plus 45 gives us 270 degrees. 270 plus 45 gives us 315 degrees. And then I'm back at 360 or 0. Now let's go ahead and let's fill all of those in with our corresponding radian degrees. So I'm going to use blue for that. So 0 degrees is 0 radians. 45 degrees is pi over 4 radians. Plus pi over 4 is pi over 2. Plus pi over 4 is 3 pi over 4. I get 4 pi over 4, which is pi. 5 pi over 4. 6 pi over 4, which is 3 pi over 2. 7 pi over 4. And 8 pi over 4, which is back at 2 pi. So now let's go ahead and let's fill in our angles. So like we said before, our coordinates. There are 4 coordinates that are easy to find. So I know that if theta is 0, that my cosine is going to be 1 and my sine is going to be 0 because the coordinate of that point is 1, 0. Coordinate of this point is 0, 1. Which means, again, I know that cosine of 90 is 0, sine of 90 is 1. Or cosine of pi over 2 is 0, sine of pi over 2 is 1. And we know that this coordinate is negative 1, 0, because from my origin I went left 1. And I know that this point here is 0, negative 1, because from my origin I went down 1. So now that I got my 4 points in, my 4 easy points, let's go ahead and let's get our other ones using our triangle. So I'm going to create a triangle. And I have a 45, 45, 90 right triangle. Move that 45 in there. So I have a 45, 45, 90 right triangle with my radius measuring 1. So that means that opposite the 45 is 1/2. Square root of 2 over 2. Opposite the 45 is square root of 2 over 2. So that means that the coordinates of my point are square root of 2 over 2. Or if we do cosine of 45 is square root of 2 over 2 over 1. Sine of 45 is square root of 2 over 2 over 1. So we get, there's my coordinates, cosine and sine. And we can continue. If I move my triangle over here, let's move some of this stuff out of our way. Oops. All right, guess I'm just not going to be moving that. There it goes. All right, so if I put my angle or my triangle here in quadrant 2 to find the coordinates of that point, I have theta here. Now my actual angle is 3 pi over 4, but my reference angle, again, is 45. So if I have a right triangle, again, a 45, 45, 90 right triangle, with the hypotenuse of 1, I know that opposite the 45 is going to be square root of 2 over 2. Opposite the 45 is square root of 2 over 2. Since I went left on my unit circle, that is going to be negative. Since I went up, that will be positive. So the coordinates of this point, all right, let me move this out of the way some more. All right, well, that's just not going to move. So this coordinate is negative square root of 2 over 2, comma, square root of 2 over 2. X is cosine, so cosine's adjacent over hypotenuse. Y is sine, so sine is opposite over hypotenuse. And I can continue. If I'm figuring out the coordinates of this point, again, I can create my right triangle, theta, or my reference angle. The full angle is 5 pi over 4, but my reference angle is pi over 4. So again, that 45-degree angle. So I have my radius of 1, so that means opposite the 45 is square root of 2 over 2. Opposite my 45 is square root of 2 over 2. So the coordinates, negative, because I went down, are negative square root of 2 over 2 and negative square root of 2 over 2. X is cosine, so adjacent over hypotenuse. Y is sine, adjacent over hypotenuse. And finally, my last point. And again, my angle is 7 pi over 4, but my reference angle is pi over 4, so 45 degrees again. So I went hypotenuse 1, so opposite the 45, square root of 2 over 2. Opposite the 45 is square root of 2 over 2. So when I do cosine of theta, I get, negative square root of 2 over 2. I went down. I get square root of 2 over 2. Sine of theta, negative square root of 2 over 2. And those are my points around my unit circle, all with my reference angle of 45 degrees. So now let's take a look when our reference angle is 30 degrees or 60 degrees. So again, changing degrees to radians, 30 degrees is pi over 6 radians. 60 degrees is pi over 3 radians. And now let's take a look at our 30, 60, 90 right triangle with, again, hypotenuse 1. So before we do that, let's fill in our degrees. So I have 0 degrees. I have 30 degrees. 30 plus 30 is 60 degrees. 60 plus 30 is 90 degrees. 90 plus 30 is 120 degrees. 120 plus 30 is 150 degrees. 150 plus 30 is 180 degrees. 180 plus 30 is 210 degrees. 210 plus 30 is 240 degrees. 240 plus 30 is 270 degrees. 270 plus 30 is 300 degrees. Plus 30, 330, plus 30, 360. So in degrees, I have my full unit circle. In radians, notice I just counted by 30 degrees, so I'm going to just count by pi over 6. So I have 1 pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 2, 4 pi over 6, which is 2 pi over 3, 5 pi over 6, 7, sorry, I skipped 6, 6 pi over 6, which is just pi, 8 pi over 6, sorry, 6 pi over 6, 7 pi over 6, 8 pi over 6, which is just 4 pi over 3, 9 pi over 6, which is 3 pi over 2. After 9 comes 10 pi over 6, which is 5 pi over 3. And then 11 pi over 6. And then 12 pi over 6, which again is 2 pi. So there is my unit circle filled in with our 30s, 60s, and our pi's over 3's and our pi over 6's. So start by filling in the 4 that we know are nice and easy. To the right, I go right 1, up 1, so 0, 1, left 1, so negative 1, 0, and down 1, so 0, negative 1. And now let's get the other ones. All right, so my angle is pi over 6, which means this is my 30, 60, 90 right triangle. So if my hypotenuse is 1, opposite the 30 is 1/2, and opposite the 60 is square root of 3 over 2. So my coordinate of that point, x is cosine, so square root of 3 over 2 over 1, and y is sine, so 1/2 over 1, but that's still just 1/2. So there's my coordinate. Now my next angle, 60 degrees, or pi over 3, so now that's 60 degrees, so my 30-degree angle is up here, but my hypotenuse is still 1. So if my hypotenuse is 1, opposite my 30-degree angle is 1/2, and opposite my 60-degree angle is square root of 3 over 2. So cosine is adjacent over hypotenuse, so 1/2, and sine is opposite over hypotenuse, so square root of 3 over 2, etc. If I move back over here, my actual angle is 120 degrees, but my reference angle is 60 degrees. So if my hypotenuse is 1, opposite is 1/2, but negative because I went left on my x-axis. And my opposite the 60 is square root of 3 over 2. So the coordinates of my point Cosine is adjacent over hypotenuse, so negative 1/2 square root of 3 over 2. For my points, if I go back to my next angle, my actual angle is 150 degrees, but my reference angle is 30 degrees. So if my hypotenuse is 1, opposite the 30 is 1/2, opposite the 60 is square root of 3 over 2. Negative, because I went left on the x-axis, but positive 1/2 because I went up on the y-axis. So my coordinates, cosine, negative square root of 3 over 2, and my sine is positive 1/2, etc. So I can keep going with my reference angle of 30 degrees. So the coordinates of my point, cosine is negative square root of 3 over 2, and my sine is negative 1/2. And then my next point, my reference angle is 60 degrees. So my hypotenuse is 1. Adjacent is negative 1/2. Opposite is negative square root of 3 over 2. So my point has a cosine of negative 1/2 and a sine of negative square root of 3 over 2. And finally, in my last quadrant, my reference angle is 60 degrees. So opposite my 30 is 1/2, opposite my 60 is square root of 3 over 2. Negative because I went down. So I have cosine is 1/2 and sine is negative square root of 3 over 2. And then finally, my last one, reference angle is 30 degrees, hypotenuse is 1, so opposite the 30 is 1/2, opposite the 60 is square root of 3 over 2. So my sine, or my coordinate has a cosine of square root of 3 over 2 and a sine of negative 1/2. And now my unit circle is complete. So at this point, please go ahead, show the substitute that your unit circle is complete, and you have the rest of the period to do your homework. Good luck. See you on Monday.